Welcome to model validation. It is an artificial intelligence and machine learning concept. So here, what is mean by model valuation? It is nothing but it is a process which help us to evaluate the performance of a trained model which we have already created in terms of accuracy, specificity, and how it is going to give us the result. So that is nothing but model validation. So how we are going to validate our model whether it is correct or not. So there are n number of types which is used for evaluating the model. One is in sample validation, the other one is called as out of sample validation. So the first one is in sample validation. So this approach involves the usage of data from the same data set that was employed for developing that particular model, and one of the best in sample validation method is the hold out method. So here the data set is divided into training data which is used to train the model and a holdout set which is used to test the performance of the method. So here the famous rule is 70-30, 70 for training and 30% is used for testing the performance of a data, and this is a straightforward method, but it is prone to overfitting because in the holdout method, if the data set is very small, this is prone to error. And the second method is nothing but out of sample validation. So this approach relies on entirely different data from the data used for training the model. So this gives more reliable prediction of how accurate the model will be for predicting the new inputs. And one of the famous method which is used here is k-fold cross validation. So here the data is divided into number of folds, that is depending upon the k value. If k is something 12, the 12 folds will be created with the data set. So this model is trained on k minus 1 folds and it is tested on the fold which is left out. Say for example, if there are 12 folds, 1 fold is left out. So 11 folds will be trained and 12th fold will be kept for testing, and this is repeated k times. Each time we are using a different fold for testing. So we get train the model and get tested the model with all the sets of data what we have, and this offers a more extensive analysis than the holdout method. So this is how the steps we follow. First, what we do is randomly shuffle the data set, followed by dividing the data set into k folds. For each group, what we use is we use one fold for testing, and the remaining groups we use it for training the data set, and we fit the model on training data and evaluate the test data, and we keep the score. And finally what we do is we get the accuracy score by applying the mean of all the accuracies of the received folds, and we can see how our model is performing. And the next method what we have is leave one out cross validation. So generally it is called as LUCV. So this is a form of k-fold cross validation where k is equal to the number of instances and only one piece of data is not used to train the model, that is kept for testing, and this is repeated for each data point. Unfortunately, this method is also time consuming when dealing with large data set. As I was discussing, in each iteration we will be dealing with one fold which is kept for testing, the other folds which is kept for training. And the next method what we have is stratified k-fold cross validation. What is meant by stratified k-fold cross validation is, in this type of cross validation, each fold has the same ratio of classes, or it can be the categories or the labels, as the overall data set. So this is useful especially where the data in one class is very low compared to other class. So this is the class distribution. Say for example, class 1 male is more and class 2 female is less. So what we do is we take different combinations of data. In round 1 we take certain amount of data of male and female. In round 2 we take certain amount of data. Round 3 it is certain amount of data, and round 4 certain amount of data from each fold. So we can have the distribution of the classes equally in each fold. So what is the advantages of model evaluation is nothing but we can check the quality of the model, we can go how flexible our model is, and whether we are ending up with any problem with overfitting or underfitting. Thank you.